For your final review of Unit 7, we will move quickly through the pre-assessment. Please pause often and make sure you go back and check your work. Okay, number 1. If it takes 1/5 of a can of paint to cover one wall, how many walls can you paint with 2 cans of paint? The first thing I need to do is figure out, what do I have? That's where I'm going to start. And what do I have? I have 2 cans of paint. What am I going to do with it? Well, I found out that it takes 1/5 of a can of paint to cover one wall, and I want to know how many walls can I paint. So what am I going to do? I'm going to split what I have apart. And what do I have? I have 2. And what am I going to do? I'm going to split it apart, which means I'm going to divide it by what? By 1/5, because 1/5 of a can of paint covers one wall. Once I found that, then I can find my answer. To show my work, I could do anything. I could draw 2 cans of paint. It's probably how I like to do it. And then I know I'm splitting it into 1/5 size pieces, so I split it into fifths. And then I see how many pieces I have total, which is 10 pieces. How should I label that? What am I solving for? Walls. Does 10 walls make sense? Yes, that is a reasonable answer. So my answer is 10 walls. Write an equation to represent the problem and the answer. See how I didn't skip this step? Make sure you don't skip any steps. Now I'm lucky because I've already done this, but I'm going to rewrite it anyway. 2 divided by 1/5 equals 10. Okay, so that way my teacher can find it really easily and I know that I've answered all the questions. Great. Number 2, there was 1/4 of a cake for John and his 3 friends to share. If they split the 1/4 of the cake evenly among them, how much of the original cake did each of the 14 kids get? Again, I'm going to start with, what do I have? I have 1/4 of a cake for John and his 3 friends. What am I going to do with it? Well, I'm going to split the 1/4 of the cake evenly among them. How many of them are there? There are 4. So what am I going to do here? Well, I have 1/4 of a cake. I'm going to divide it, split it, between 4 kids. So that means that I could have, again, I like to draw it. Here's my whole cake, right? But I know that all I have left is this 1/4 of a cake, right? Now I'm going to split it into 4 pieces. So I split it into 4 pieces. Now that I've done that, how much is one kid going to get? Well, one kid is going to get this piece of cake right here. What is that worth? Well, because I know that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces. I know that that kid is going to get 1/16 of the cake. And does that make sense? Yes, it does, because they're going to get something less than the whole cake and something less than the 1/4. So my answer makes sense. If I write an equation to represent the problem and the answer, I would write 1/4 divided by 4 equals 1/16. Okay, remember, we're always thinking about, what do I have, what do I do with it, and is my answer reasonable? Moving on. Number 3, Miss Hall's class is planning a water balloon fight. They found 2,498 balloons in the cupboard. How many water balloons will each of her 28 students get if they share them equally? Again, what do I have? Turns out I have 2,498 water balloons. What am I doing with it? Well, I'm splitting it up in between students. How many students am I splitting it between? 28 of them. So I'm going to start here at step 2 just so I can write my equation really neatly. Okay, so I know that I have 2,498 water balloons that are being divided by 28 students. Now I don't have my answer yet, but what I need to do is I need to solve the problem. And how do I like to solve division problems? My favorite way is a ratio table. So that's what I'm going to show you today. Okay, so I create my ratio table and I'm going to call this students, and I'm going to call this balloons, okay, because I want to figure out how many balloons each student is going to get. So I know that I have 28 students, and I'm going to start them off with 1 balloon each, okay, but I need to get all the way up to 2,498, okay, so that's where I'm headed. Now let's say that I'm starting off with my one group of 28. Okay, now I might think to myself, well, I can multiply 1 by 100 and 28 by 100, because whatever I do to the bottom, I do to the top, whether it's multiply, divide, add, do groups, whatever it is. So I multiply by 100, and that's going to give me 2,800. So what I found out is that's a little too high, right? Okay, that's too many balloons. 2,800 is too high for me. So I'm going to have to take away some groups. Okay, so maybe I think to myself, well, what is 10? 10 is 280. Okay, so this is looking a little more reasonable. So now maybe I'm going to guess to myself, 2,800 minus 280 equals what? Let's see. Let's find out. That would give me 0, I carry the 7, make this a 10, 2, 5, 2,520. So I'm getting closer. Basically where that puts me is it would tell me that if I had 90 balloons for each kid, then there would be 2,520 balloons, right? That's what this tells me, because if I take 100 minus 10 and I take 2,080 minus 280, that gives me 2,520 balloons, but that's still too high. So maybe I decide to take away a group of 28, okay? Maybe I take away one more group. Would that put me at? That would put me at 89 balloons per kid, right? So when I look here, then I think to myself, okay, well, I'm going to do some subtraction. Can I take 8 away from 0? No. So I'm going to trade this in, change this to a 2. Can I take 2 away from 1? No. So I'm going to trade this in, make it a 4, and then I have the new number 11, and that gives me a 9, 4, 2. And then what do I see now? Okay, so now I'm at 2,492. Now, when I look at that, I think, okay, well, wait a minute, that's below what my number of balloons is. So my answer would be 89 with a remainder of 6, okay? Because I have 6 balloons left over. Now, what do I do with the remainder, if any, and why? In this case, I probably wouldn't do anything with the remainder. I would leave 89 balloons per kid, right? And then I would think to myself, well, maybe I give 6 to the principal, okay? In this case, my answer would still be 89 because I can't split those 6 balloons. If I try to split a water balloon in half, I'm going to break it, okay? But I still need to explain what I do with the remainder, all right? So it doesn't change my answer in this case, but I am going to have to do something with it, which you can get a little creative with. You can't split it into a fraction because you can't split up water balloons, and we can't make it a decimal because, again, you can't split up water balloons. If you split them up, you break them open. So we know that we have to use them in a different way. Okay, let's move on to number 4. The 789 students in Brown Elementary are going on a field trip. Each bus holds 32 students. How many buses do they need? Okay, again, I'm going to think to myself, what do I have? I have 789 students. What am I doing with it? I'm splitting them onto buses. Each bus holds 32 students. What am I trying to find out? How many buses do they need? So I know that I have 789, that's what I have, divided by 32, that's the number of kids on buses, and I'm trying to figure out how many buses they need. Okay, I like to label it because then I help myself remember. Now, again, I'm going to start with a ratio table. Okay, and I take my divisor, and my divisor is one group. Okay, so one bus, 32 kids, but I need to get up to 789 kids. So maybe I multiply by 10. Nice and easy. Okay, multiply by 10, I get 320, adding that power of 10. That's awesome. Now maybe I think to myself, well, let's multiply by 2. Okay, so if I go times 2, then I get to 20, and this gives me 640. Am I there yet? Not yet. Okay, so now I'm thinking to myself, well, I'm getting pretty close to 789. Maybe I could just add like 2 groups of 32. 2 groups of 32 is worth 64, right? And if you're not sure that that's what it is, always show your work. So I'm going to write down over here 640 plus 2 groups, which is 64, and I'm just going to see what that equals. So that will give me, carry the 1, 704. Am I there yet? Not yet. But I'm thinking to myself, well, what if I add another group of 64? So that takes me to 24, right? Now I have 8, 6, 768. Now I'm really, really close, right? So now I'm going to think to myself, well, what if I add a group of 32? That gives me 800 even, okay? So 25 is 800. Now, I have to get all 789 students, but each bus only holds 32. So I saw that my answer was 24 with a remainder, right? But it doesn't really even matter what that remainder is. I could solve for it. That would be no problem. I would see that it is 21. But What I know is I can't leave those 21 kids out in the cold. They can't sit in somebody's lap. So what did I do with the remainder? I made my answer 25 buses because we're going to need an extra bus for those 21 kids. Okay, and I would explain that because all kids need a bus. Okay, and hopefully you guys are using text boxes rather than writing messily like I am, but you know, we can all hope for being better every day. Next. Number 5, solve each problem, show your work. So for all of these problems, again, you could do a ratio table or you can draw a model. I'm going to quickly do those and then we'll look over them together. If you have any questions, do pause the video here and look through it on your own to make sure that you're getting your answer correct. Okay, so take a look at all of my work. You'll see that for A, the answer is 35, okay, and I counted all the way up to my, sorry, it's 37. Gotta check your own work sometimes. Okay, so I counted up by 10s at first, and then I went back to 35, and then I went up by 5s, and then up by 1, and then up by another group of 24, okay, to get me to 37. Here, I went up by 10s, and then I found once I got to 20, I was too high. So I figured out what 5 was, and then I subtracted my group of 5, then I added to 15, and then I added another group of 1, okay? So any order is fine. You can go backwards and forwards in ratio tables as much as you need. For C and D, I took what I have, and I drew models because that helps me think about fractions. So if I have 6 things and I break them in half, then I get 12 total things. Smaller pieces, but more of them. If I had 1/2 of a pan to start with, I like thinking of 1/2. I like thinking of my fractions as brownies always. I split it into 4, then I get 1/8 here, okay? Again, if you have questions about this, do make sure you take the time to ask your teacher today or pause the video and look through all of these different answers. Next, multiply each whole number or decimal by powers of 10 using the steps shown in the example. Okay, so we know that the exponent here will tell us the power of 10, just like they show us here. So it says using the steps shown in the example. So do what the example does. You would take 79 times how many 10s? 10 to the third. So in parentheses, 10 times 10 times 10 equals, and then we would do 79 times 1,000 equals 79,000. Okay, there's my 3 zeros, there's my 3 place values. Okay, they all stay the same. Here we have 10 to the second, here we have 10 to the fourth, and here we have 10 to the fifth. So I'll repeat the process for all 3 of these really quickly, and then we can take a look at them. So now that I've done these 2, let's take a look. I have 3,153 times 10 times 10, 10 to the second, which is 100. And then all I do is I take and I add my 2 place values at the end. The next problem is a little different because we see a decimal. The decimal is part of one of those zeros, in quotes, or place values. So here I see I'm changing by 4 place values, 10 to the fourth, which is 4.7 times 10,000. In this case, my answer is 47,000 because I moved the decimal from here, so this 7 is 1 place value, then all 3 of my zeros are 1 place value. So there's my 4 place values. In the final problem, we have 0.066 hundredths times 10 to the fifth, so 10 times 10 times 10 times 10 times 10, which equals 6 hundredths times 100,000. Okay, sorry for my messy zeros. And then what I'm going to do is I'm going to move my decimal point and then add as many zeros as needed. So I see that these are 2 place values already. So then I know that I start with a 6, but I've already moved 2 place values, and then I add 1, 2, 3, 4 zeros, okay, because I already added my 2 place values, so my answer is 60,000. Always remember that the numbers after the decimal count as place values, so you don't need to add extra zeros for them. You just need to move the decimal over and then add as many extra zeros as you have left over. In this case, I started with 5. Oops, not 6. Good thing I checked my work. So I would go back and I would find that my answer is actually 6,000, okay? So always good to check your work. All right, next. Solve the multiplication and division problems below. All of these are again using powers of 10. So if I'm dividing by 100, that means that my decimal point is moving 2 spaces back. So my answer here is 78 hundredths. If I'm multiplying by 100, my decimal moves to the right. Okay, I'm multiplying by a number greater than 1, it moves to the right, which would give me 29. I'm multiplying by 1,000, which means my decimal moves 3 place values to the right. 1, 2, 3. So that would give me 5, 4, that's 1, 2, 3, 5,400. Then I have 0.9 times 0.1. Now, this is a smaller number, so that means my decimal is going to move to the left, okay? Smaller than 1, my decimal moves to the left, which means that 0.9 times 100 is 0.009, 9 thousandths, okay? 3.27 divided by 1/10, okay? If I'm dividing by a number smaller than 1, then my decimal point is going to move right, okay? Always counterintuitive because I'm having more pieces. So now I divide and I find that my answer is 32.7, okay? My decimal moves 1 place value to the right. I have 32.7 pieces. They're smaller than 3.27 was, but there are more of them, okay? And 251.6 divided by 100, I move this 2 place values to the right, so I get 2.516. Okay, and if you want a review of those rules, remember you can always check it out in the last videos, or you can look at these rules here in the review video from yesterday. Finally, Olivia solved the problems below and got all the answers correct. Describe what is happening to the decimal point in these problems. Okay, so what you see, she's dividing by 10, she's dividing by 100, then she's dividing by 1,000. You see the decimal point moving farther and farther to the left. So if I was describing what would happen, that's exactly what I would say. The decimal is moving left 1 place value in each problem. Why does it work that way? It works that way because each problem is being divided by a power of 10, 100, 1,000, and when you divide by a power of 10 greater than 1, the decimal moves left, okay? When you explain a problem like this, please use mathematical language like this. So let's look at number 10, our last problem. Sam solved the problems below and got all the answers correct. Go, Sam. 10 to the first, 10 to the second, 10 to the third, 10 to the fourth. I notice. What is happening to the number of zeros in the problem? Well, if you notice, they're increasing by 1 every single time. Why are they doing that? Well, they're doing that because it's increasing by a power of 10 every single time. So I would write something like this. As long as you are using language that shows that you understand that you're increasing the place value and you're using powers of 10, those are the kind of language that we are looking for. So words like place value, increase, powers of 10, okay? Those are the kind of things that we are looking for when we are asking you to answer these problems, okay? So, good luck with your studying, and please ask your teachers if you have any questions. You're going to do great on the test tomorrow.